Hello, everybody. My name is Pierre-Yves Ricau, and I work at Square. I'm a software engineer. I've built several APIs, SDKs in my career. I wrote, a long time ago, I wrote something called Android Annotations, which was more of an experiment. A couple of years back, I wrote something called Leak Canary, which if you're using, you might hate because it's kind of always in your face. But as I was doing that, I had to build APIs. More recently, I joined a team that is focused on building mobile commerce SDKs at Square. So that team is actually here. They're all here, the Android team. Say hi. They're great. And they're watching me. Every word that I say, they're going to then tell me that I'm wrong. So we've been doing that, and in August, we released a new SDK called the Square Reader SDK. And so I'm not going to spend a lot of time on that because you probably don't care that much. But essentially, it's an SDK that connects to the Square hardware, the payments hardware, and allows you to make a custom point of sale. So we're building that SDK, and we're like, well, we're Square. We have all these open source libraries. We need to make a good API for that SDK. Why do we need a good API? What happens when you have a bad API? When you just write something without thinking and you just ship it. Usually, even if your code is perfect, if the API is weird, like fragment, I didn't say it, then developers will introduce bugs in their code when they use your APIs. And then they'll be angry, and you don't want angry developers because then they're going to be angry. That's not good. You don't want angry customers. Anyway, there's a quote that I really like that is kind of like obvious, but I still really like it, and that's what the talk is going to be about. So Josh Bloch, I don't know, said, probably Bloch, APIs should be easy to use and hard to misuse. And when you look at that, you're like, well, obviously, that's not like crazy genius. But it's interesting, if you start digging into what each part actually means, we can get into some really interesting stuff. So today we're going to dig into what that means, but before we dig into that specific sentence, let's talk about the how. So kind of to get rid of the room, who likes to write clean code, good code? If you don't, that's kind of weird, but right, we all like writing, to write good code, right? And we all like to make the code better, right? Now the problem is the best practices are always changing. You have to write tests. You need to use maybe interfaces to make your code testable. Oh, now you need to do immutable data structures. Or you should write a reactive data flow with MVVV, MVP, and with coroutines, and also RxJava, but only in that case. And so I'm going a little bit overboard here, but I'm not going to talk about any of that today. And the reason is those things are important. They're also always changing. And I'm a little bit more interested around maybe in part the process and the general ideas. One of the things that I've learned that I find really fascinating is the idea that there is no absolute best API. So let's take an example. If I tell you coroutines today, you may be aware, Kotlin is we're all excited about Kotlin in the Android community, and there's this new thing called coroutines for handling async work, deferred work. And I'm not an expert in that in any capacity. In fact, I still have a hard time understanding what's going on with coroutines, and I believe a lot of people do. A couple of years from now, it might be different. So if I was to write an API today for a product or something, I might not use coroutines, even though there's async stuff, just because a lot of people would be confused. In the future, maybe that'll be the default, because that's going to be the first thing you learn out of school. So as you can see, it's kind of it depends. Another example, maybe I'm going to write an SDK with static methods everywhere. If you're a more senior engineer, you'll be like, I hate your SDK. I want to be able to test. I can't test static methods. But if you're a beginner, it might be easier. So the point is, we write code for other people to read, and then these people, they don't all have the same skills, the same knowledge. So when you write an API, you have to think about who's going to use your API. And it's not this abstract developer that is exactly the same person as you are. Because that's usually how we think, like, oh, I know how to use this, so that's what my API should be. But the people who are going to use your API are different. And so it's important to try to think, okay, who's my target here? And the other thing that really helps, okay, who builds apps here? Who has built like an Android app or a product? All right, so you're used to building products, and by now, hopefully, you know that we don't do what is it, cascade, whatever. Like now we're in an agile world, right? We iterate, right? That's what we do. So when we build products, we ship something, we see what people do with it, we get feedback, and we're like, okay, we need to improve it, we change something, we release a new version. Now, can we do the same for APIs? And you just saw the slide. The problem with doing that is that changing things usually means introducing breaking changes, which means requiring changes in the code, updating the code. And this makes your customers, the people who use your API, it makes them angry, right? So what's likely going to happen is A, they're going to be angry, B, they're never going to update to the new version because you broke them. Maybe they'll do it the first time. If you do another big change, they're basically never going to stop. They're never going to use your API again. So here's some examples. You have to think about the transition. One example is like if you've used retrofit or OKHTTP, I believe those were fairly easy to migrate to, some packages to change, overall kind of the same shape. You kind of get the idea and you quickly get there. One example that was the total opposite was Dagger. Migrating from Dagger 1 to Dagger 2, it's like, no, it's really hard unless you just write from scratch and forget it, or you don't have a large code base. So that's an interesting example of how migrating can be hard, and therefore, how can you iterate on your API if you can't change anything, right? And you know the answer. The answer is we're going to make an alpha. And we're going to say that we're going to break everything, but it's OK because it's an alpha. Right? And that's why you see all these libraries that are in version 0.1 and keep iterating. The expectation is that the API will change. So when you're building a product, the tricky part is thinking about that, because you're working on adding features to your API, building everything else you need, and you might think, oh, I'll figure out the API later. And that's wrong. You really need to, it doesn't mean you have to figure out it first, it means you have to try something, iterate as you're building the other stuff, and get feedback. Now, getting feedback is interesting. If you send an API to someone, I've tried many times, and you're like, can you try this, tell me what you think? They're like, oh, it's okay, like I had a problem there, but like it's fine. You basically don't get much feedback, right? It's really hard to get valuable feedback from developers. They don't want to be mean to you, so they're not going to say what they think. And sometimes they don't even know, they just got a problem, they don't quite know why. So one way to get feedback is to play with your API. So it's kind of self-feedback. You write an app that uses it. But don't write a toy app. Write a real use case, right? Like, if you're just making a toy app, you're kind of not going to see all of the edge cases, and you're not going to think about a bunch of use cases. So it's nice to build something that's going to be like real or almost real. And as you change the API, see how this application changes. One example for us was that we've been building Kotlin and Java apps that use the same API, and it's been really interesting because it tells us when we that we didn't think about this case, or like extension functions, and what about this, and so or nullability. And so having these two example apps, when we change the API, we can check and make sure that it feels good on both in both languages. Another way we got a lot of great feedback was we just gave the API to our doc writers, and we say, hey, write the doc. And then they wrote the doc, and then we read it, and you're like, what? And so that helped us like realize, oh, I guess this API doesn't make any sense without any context, right? Documentation is important, but having someone to try to write documentation for your API is a great way to get feedback around what's confusing, because they're going to write confusing things, and then that helps you point to where the things are wrong. Another way to get feedback, you might have heard of usability testing. It's a big word. It sounds complex. There's like, okay, you could go scientific and like academic on this. You could say, I'm going to sit down, record what you're doing. You can measure the complexity of an API. You ask someone to do a task, and you measure how long it takes. And you do that with a bunch of people. And then you try different versions, and you measure how long each take. And then you're like, okay, this is the complexity, so this is better than that in this context. But no one has time for that, right? Like we don't have time for this. So there's just a cheap way, which is you ask someone to come, you sit in a room with them, and you ask them to do something, and you take notes. And maybe you record the screen. But the big part here is being there in person and watching them react. Because what's going to happen is you'll see something like, oh, sorry, I made a mistake. I didn't read carefully. My fault. Don't worry about it. Right? People are going to say that. And when they say that, you should really pay attention to what they're saying, because it's not their fault. There's something wrong with, maybe you wrote everything in the documentation. There's just too much documentation. So they just kind of skipped over, and then they missed a critical step. So all that kind of feedback is really interesting. And then there's another really good way to get feedback. It's kind of sneaky. So say you make an alpha, you give it to a bunch of customers, and they're like, oh, it's great, it's working great. Then you download their APK, you decompile it, and you look at the sources, or the decompiled sources. And you figure out that what you thought was so obvious, and that's the only way they should do it, well, they did it differently, and maybe in a way you didn't expect. And we learned a lot that way. So that's kind of it on the process side of things. And I want to come back to that sentence. So, easy to use. Okay, it sounds super subjective, right? Like, what's easy to use? My stuff is easy to use. In my mind, there's really two dimensions here. One of them is that the API has to be intuitive, and the other one is it has to guide the developer for the stuff that's not intuitive. And intuitive, it sounds kind of like a magic word. Like, what does that mean? What is intuitive, an intuitive API? Like, to me, it's really, I know how to use it without having to think too much about it. And how it comes, how does that work? Well, it's pretty simple. Most of you probably know how to ride a bike. It's probably intuitive at this point. It wasn't intuitive when you started. There's a bunch of things that you do in your everyday life. You see a door, you've never seen that door before, but you know how to open it, right? And that door is probably intuitive unless it's a stupid door, and that happens every now and then, and it's the wrong way. But that's just the door that's wrong, it's not you. So nothing is intuitive in a vacuum. It's all based on your prior knowledge and experiences. And one of the main drivers of something being intuitive is consistency. So, okay, if you're like humans, you probably immediately noticed that there's a bunch of dogs. You maybe didn't even count the dogs, but you know that there's a cat in the middle. You immediately, found the cat, right? That's like the first thing you do. Right? Dog, oh, there's a cat here. Something is happening there. What is this cat? What is it about? It's to show that as humans, we're really good at pattern matching. Our brain just scans something and finds the differences, finds the similarities and the differences. And that's really what's going on with something being intuitive. It's like, I've learned about the system, I learned about how this works, I can do it again, and I don't have to think about it again. So there's kind of different types of consistency in the world of APIs and SDKs. One that I could talk about it, people could talk about it for hours, but it's called domain consistency. And there's a whole field called the domain-driven development, where people dive into how to correctly design the domain of your problem. But really, what I'm interested in here is like more like high level and more remote. How do you, so domain, what is it? It's the words that are specific to your problem. Like Square, we deal with payments, transactions, taxes, that kind of stuff. This is like the domain, as opposed to a view, a controller, whatever, that's not the domain. So when you have an SDK, you have to think, okay, what are the big words? Is it a payment or is it a transaction? I kind of have to choose. I can't do both. But when you're building an API, you have to think about the people who are going to use that API. Sometimes you have to choose between the correct word and the word that people understand. So for example, big decimal. It's got this add method, and add takes an OGAND, and subtract takes a subtrahend, I guess. Okay, who had heard of those words before? OGAND, subtrahend. You can raise your hand, it's okay if you do, but it's also very okay if you don't. And big decimal here is trying to teach you something, and you don't need to know those words to be able to do an addition or a subtraction. And so an API shouldn't try to teach you something. Okay? So that's the first thing. I'm going to go back to the SDK we're shipping for like a couple of minutes, just to kind of show you what we're doing. Our SDK essentially has got 3 main operations. The first one is you authorize it. It's like an async call, okay? And then I'm in the authorized state, and I can add a reader. So you're Android developers. This is like just, I can start an activity, it's going to show this UI, I can connect the reader, the activity finishes. Similarly, I can start a payment. It's going to go through the UI, and then it's going to return the result, and I'm done. That's it. That's the entire surface of the SDK. Sounds pretty simple. Still, we had to think a lot about the API. So finding the best words for us meant choosing for those kind of 3 things that I described, choosing the words. And so it was authorization, reader settings, checkout. We could have picked a bunch of other things. Checkout was interesting. We could have said start a payment or start a transaction. But we decided that because we were doing tips and signature and reset, it was more than just payments. On the smaller side of thing, so this one is kind of interesting. We had this enum, so you take a payment, you get a result of like, okay, this is the various ways, the various types of transactions that you can do if you want. So you can type in the card number, which was keyed. You can swipe a card, swiped. You can insert a chip card, which the protocol is called EMV, so it's an EMV transaction, and you can do a contactless transaction, like when you tap with your phone or your card. What was interesting about that is that it doesn't quite make sense. And the reason that we had this specific enum with these specific values was just because that's what we had internally, and we just copy-pasted it and published it. But when we tried, so here's one thing that's interesting. What does keyed mean? I don't even know what is a key? Like, how does a key has anything to do with this? EMV is a specification. It turns out that the contactless is part of the EMV specification. So now we have one EMV entry. The only reason it's like this is because we started with swipe, and then later on we added chip, and we're like, oh, this is the EMV spec. And later on we added, oh, contactless. We just added it at the end. So we changed to new words. And so we thought, how do we find the right words for this? And not the correct word, the words that people understand. We went to our marketing web pages, to the stuff that the public pages, the words that we use publicly that are targeted at normal people. And we found that people were saying like, oh, we swipe, we use the chip, we use contactless. Okay, those are the words that we want to use. And then you find those words and you decide to apply them everywhere. Everywhere means everywhere. So obviously methods, class names, Javadoc, documentation. It turns out it's really hard. So we're shipping SDK on Android and iOS, so we have 2 code bases. Getting the Javadoc and the JazzyDoc to use the same words. You don't say start a payment and then take a transaction and then charge a customer. If it's all the same thing, it should be all the same sentence. Setup guides, everything had to be updated. And the third step was like structuring the code around those concepts, and I'll get to that. But essentially, so that's what like domain consistency is about. Now, you're Android developers, you may be iOS developers, you may have peers that are iOS developers. The little robot is Android, the little apple is iOS. I like to use that in our docs. So you might have seen that in several SDKs where you use an SDK and you're like, that's kind of weird. Like this Android SDK is saying, do this with application holder and blah, 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 and blah, blah, blah. Or maybe you'll see something called like a delegate, but it's not a Java delegate. Maybe you'll see something about view controller. So there are a bunch of words that are specific to our platforms, right? On Android, we often talk about callbacks, we talk about activities and views. On iOS, they talk about maybe delegates. We have builders, they have configuration objects. They have view controllers. We don't really have anything. Maybe view model now, maybe. It's not, the jury is still out. So this is kind of interesting, right? Like there's this difference. And so basically, when you design your API, you have to agree on the domain. This is a payment. But then you might say, start the payment controller, or you might say, start the payment activity. You might say something else. So, you know, like it's okay to have different APIs as long as the domain is identical. The API has to feel like it's a real Android or iOS API. Another trick we used is because, so we use words like callback, call, stuff that's like fairly common. So if you obviously you want to use a package name, you're going to put a package name, you know, everything is going to be in a singular package that's going to be whatever your SDK package is. But because you might have conflicts because you're using words that are common, people are going to have to use sometimes the full package name. So if your package name is com.mycompany.sdk.blah, it's really long, and it's going to be annoying to people. So there's an easy trick. You might have noticed that OKHTP, Retrofit, a bunch of other libraries have very short package names. It's just one word. That's an easy way for people, if they need to use the fully qualified name, they just use this one word dot something. And it makes things much easier when you have to differentiate. So applying self-consistency, And so the last type of consistency is self-consistency. You don't ship an SDK where one method is remove and the other one is delete. Because if I show you that, you're like, well, I don't know. Like on this object I can delete, on this object I can remove. Is it different? Is it the same? What's the difference between the two? If you have builders, you have to decide, is there a create method on the builder? Is there a new builder? Is there something? You have to define what the style is. There might be some general practices, but at the end of the day, it's not so much which one you pick, as long as you pick the same thing throughout. Once you pick the style, you try to find inconsistencies in your code base. You go through the entire API, and then you try to find inconsistencies again, because you're going to miss some. So we did that. I'm saying do it again because we did it once, and then we did it twice, and we found some like stupid stuff. Like for example, this was a very early version of our API, but login was lowercase and logout has a lowercase o, and I couldn't explain it. We just had typed it that way. It's kind of weird. So this is the kind of stuff that you can look for. So we talked a little bit about intuitive and how it's about being consistent, because if you're consistent, you're going to know what to do next. Now let's talk about guiding. So what's the first thing that comes to mind when you talk about guiding developers to use an SDK? To me, the first thing that comes to mind is documentation. That's kind of our fallback. Actually, a lot of time what you'll hear is like, oh, yeah, this isn't quite like obvious. We'll just add some documentation for this, right? We all do that. So there's different types of documentation. One of them is a quick start guide. So there's a rocket ship over here. The quick start guide is this concept of like, I'm not trying to teach you anything. I want you to feel good about my API, right? It's just a feel-good thing. So I'm not going to tell you to write all this code or how to integrate into your app. I'm just going to give you like, hey, check out this repository, run this like stupid command. Wow, you just made an app. Like, wow. You didn't really do anything, but it feels good. It's like, oh yes, it works. It's an SDK that works. It's pretty rare, So it's amazing how people feel about this kind of quick start stuff. Then they're like, okay, I want to use it, and that's when you make a setup guide, which is more about how do you bring that SDK into your own app. And this is actually one of the trickiest things to get right, Because you need to educate people. You need to tell them, well, you should do this, you should pay attention to that, to this specific part. But as you start doing that, and as people make mistakes, you start adding more stuff, you end up with, 5, 10 pages of documentation. And you've all done it, we all do it. You give someone a guide, they scan through it until they find the code, they copy-paste the code, scan, find the code, copy-paste the code. And all the words that you typed in the middle, no one pays attention. So sometimes people add warning signs, but as soon as you have more than one, same thing, we don't pay attention anymore. So it's really hard to get that right. One thing that I want to call out in both the Quick Start sub-guide is something called example code. This one is tricky. The first thing we do when we write example code, we're just like, this is how you use it, this one line of code. So there's kind of two things. The first thing that's missing with example code oftentimes is the context. It's like you'll see a method call, it's got this as a parameter, you're like, what is this? I don't know. But more important than that, so another quote from the same person, example code should be exemplary. It's got a nice sound to it. So what's going to happen with your example code? Like I said, people are going to read through, copy paste, right? Now, if you're like most people, when we write, say, a sample app, we're going to be like, oh, blah, 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 comment, to do in production, you should do this. Don't do this now. But this is an example app, so it doesn't matter. Next thing you know, people copy paste this block everywhere in their production app and ship with it because they don't have time for that. So that's why example code should be exemplary. That's why we try to build sample apps that are real, because otherwise, soon enough you realize that you're like, oh no, you don't do that, and people just do it. So it's much better if you can stop. And that happens all the time in every single SDK I see. It's like, oh, and here you would call the server, but we don't do it right now. Oh, and you have to do that off the main thread, but let's just show you on the main thread right now. That's how these things work. Last, when guiding, Javadoc, all the things, right? All the types, all the methods. You just want someone to look at it and be like, oh, okay, this is what it is, even if you're just linking to something else. Fairly common to have a Javadoc jar so that they get that in their IDE, but also a source jar, even if your SDK is not open source, that's okay, but take the parts of your APIs that are APIs, put that into a jar as sources and upload that to, say, Maven or whatever your repo is. Because if you do that, then when people will be in the code, they can come and click. They might not be able to see the implementation details, but at least they can see in place, and it's really nice when you can see in place the Javadoc and all that as source. All right, so is that it? Is that all we need, documentation? Well, there's another thing you can do to guide developers, and it's 2018. We have wonderful IDEs, and we use a language that is not JavaScript, so that's pretty great. Developers can use autocompletes. So you can type a thing, and then you get all of the options that you can do. So this is great for guiding, because you basically tell people, hey, this is just where you you start looking here, and then you'll figure it out. Now, you might notice here that there's a lot of things going on in there. And this is actually probably too much. When you're in your IDE and you type this is what you're going to do. You're going to start out at the top, and you're going to start reading until you find something that sounds like what you want to do, right? That's what we do. There's actually a bunch of scientific studies that says that the time it takes you to find the right method is in a linear complexity, meaning the time it takes is proportional to the number of methods that are there. So, which is obvious because you're scanning from top to bottom until you find the one. But they did a research study on this, so that's great. So for us, we looked at this and we're like, well, we can do better. And we thought about this concept. I talked about domain and structuring the code around that. So we said, well, what we're going to do is we're going to group around those three concepts. So you're going to get, I don't like the word manager, but we couldn't find anything better, so whatever. We're going to have a checkout manager, authorization manager, reader manager, and then you dive into one, you pick a concept, and then you get more methods to do more things related to that concept. And there we had a state object that you could get, and then the state object had more information. So you kind of have this tree. It's more verbose, but it's way easier to discover. All right, so we talked about easy to use. So let's talk about hard to misuse. How do we make APIs hard to misuse? Well, it's kind of three things. The first one is we want to prevent mistakes. But if they happen, we want to give feedback. We want to correct mistakes. Also, sometimes people do mistakes on purpose, and you have to look at this because it's kind of interesting. So preventing mistakes. There's kind of two ways, again. First one is documentation. And we just talked about how if we have a lot of documentation, people just don't pay attention. It's really hard to find the right thing. And also how code, example code is part of that documentation and helps you prevent mistakes by guiding people towards the right patterns. API design is a much more interesting way to prevent mistakes. So let's look at some examples. So here, all right, so if you've used Android before, you know that you can do, or you may know, sorry, that you can do start activity for result, starts an activity, and then later on, when the activity is finished, you have to implement an activity result, and you get an int request code, which is what you started with, an int result code, which tells you if it was success, whatever, it's an int. You can do a lot of things with an int. And a third thing that is a data intent. So because our SDK was shipping activities, we're like, well, we started with this. It was just like, okay, well, if I try to start this thing, and if the result is not success, or if it's success over there in the second one, then parse the intent, give me the object, and then handle that. So the first thing we can talk about, and that's kind of a nit, but you can see that here we're just like, we had two different operations. They actually could fail in different ways, but we put everything in their one enum. So in your error code, you had to know, oh, wait, this is that case, so I only have to handle those two. So obviously, that's pretty bad, and that's pretty easy to fix. You just separate one enum per use case. That's simple. But more interestingly here, it's really easy to make mistakes, because we have a bunch of ints. What if I check against the wrong constant? And also, I have to check for every single entry. I have to check all these things. Data could be null. This code actually doesn't check for data being null, but what if data is null? That's a thing that Android does to you sometimes. So we looked at this, and then kind of had what I thought was a great idea. But I don't think so anymore. But let's get into that. So we said, all right, maybe we can abstract away all that complexity. It turns out that there's another type of Android component that gets an activity result calls. It's a fragment. And so if you were to install a fragment inside an activity and call start activity from that fragment, then an activity result would be called on that fragment. So we thought, hey, you know what? When you're going to call start checkout activity, instead of just starting the activity, we're going to install a fragment called start activity from that fragment. That way, it's going to be a retained fragment. It's going to survive rotation, so all that. And then when the activity result is sent, our fragment gets it, and then you can see that there's a callback that you can add, and it's going to call that callback. And it felt nice because it felt like it was abstracting. Yeah, you don't have to implement all this activity stuff. You just do whatever you like. It works. So the code would look like this. You'd create, you'd get an instance of the manager thing. You would say, hey, add a callback from your onCreate. It gave you a callback reference. You would clear that reference in onDestroy so that prevents memory leaks with activity rotations. And then when you started the callback, you would pass in the activity, and that's where we would install the fragment and do all the things. It sounded great. And then one day, we had a customer having issues, and we were trying to debug, so I did the sneaky thing. I decompiled the code, trying to look at what was going on. And this is essentially what I found. I found that so it's not in an activity, in a separate part of the code. They were just calling start checkout activity, and then immediately setting a callback and clearing it from the callback itself. Now, the problem with that is that the whole design was so that you would be able to survive process death. because the fragment was a retained fragment. It would reinstall itself. But that required that you added the callback in onCreate of your activity, because when you restore process, the activity is back and it adds the callback and everything's fine. But here that wasn't the case. Clear bug. And overall, we tried to do this design to help both the beginners, like just an activity, and the more advanced people who want view model, they can just, it was easy enough to put into a view model. But it turns out that by trying to abstract away complexity, some of that complexity is still leaking, and at the end of the day, you may not be making things easier. If I was to do it again today, and in fact, we're working on a new, completely different SDK, I can't talk about it, but it's got activities as well. This is probably what we would do. Instead, we'd say, you know what, just do an activity result. But we're going to get rid of all those ints. We don't need them. Just give us the data object. And we're not going to return anything. You're going to give us a callback that we're going to call immediately, if this is something that matters to us, if this is our result. So if the data is null, you just ignore it, whatever. So this is kind of, this feels simple enough. You get something typed. You don't have to deal with ints. You just pass an object, a callback, and you're good. So you'll notice that there's a static methods. If you want to have tests, maybe you're going to need to introduce an interface for this. That's fine. It's your job. So you can see how there's, like, sometimes you want to do something smart that you think is going to be great, and sometimes you realize that it's not actually, it's really hard to anticipate what people are going to do with your code, which is why sticking to fundamentals can help. Okay, we talked about preventing mistakes. What about correcting mistakes? So what is the best time to correct a mistake? And I guess it's kind of like preventing a mistake, because it's typing time. I'm doing something, and then my ID tells me, nope, don't do that. So, obviously types, what you can do with completion and stuff, but also lint checks. They can be great to immediately give you feedback like, oh, that's an anti-pattern, you shouldn't do that. The big problem with lint checks is that they can be wrong, and if there's a chance that they're wrong, then they're going to start adding noise, and you start getting all those warnings, and you just stop paying attention to them, right? So it's really hard to find that correct balance for lint checks. What's the next way to correct mistakes or give feedback to correct mistakes? It's build time. So, if you use Dagger 2, you get like these compile errors. Build plugins, that kind of stuff. It's a great way to provide feedback. Basically, the faster you provide feedback, the better. Then, app startup in debug, right? Like if you have something that can check for errors, do it when the app starts and just crash immediately, or do something that's people are gonna notice and they're gonna fix it immediately and they're never gonna ship it. It can be a bit frustrating, but it's not bad. Then the one that's tricky is when the feature is triggered, because if they test in development, it's great. They're gonna get the feedback that something's broken. If they don't, it's gonna ship to production, and that's really bad. So we try to avoid that, but so it's kind of like you have to think, when you're identifying mistakes that people can make, you should push as much as possible to the top to like quick feedback loop. There's a difference though between, well, let's rephrase that. There's something called errors. So SDKs sometimes provide you with errors. And you really need to differentiate between these two kinds of errors. The expected errors, so this is something that will happen. Like the password is invalid, or there's no network. It's expected. It's an error, but it's expected. The app is not installed, whatever. And there's mistakes, developer mistakes. We use the term usage error. If you say, oh, you did a mistake, people are going to feel insulted and they're going to be angry at you. If you say, oh, sorry, it's like a small error, nothing big, don't worry about it. It's just a small usage error. It's kind of nicer. But the usage error, the mistake, is someone wrote incorrect code. And the important thing here is, so this is an example of a error type with a generic parameter for like an error code. And you get a message that you can display to the user and maybe some more debug information. The thing that's important here is to separate out all the usage error kind of errors into one place, and you absolutely do not want to list them anywhere. You might list them on your website, but you do not want to list them as enum values or as types, because think about it. If this is like an error that happens when someone writes incorrect code, do you expect them to also write code to handle the fact that they wrote incorrect code? Like, there should be a generic way to do that, but they shouldn't do like, oh, if I pass null here, then this is what I'm going to do. If I did this other thing, this is what I'm going to do. No, there should be like the errors that are expected to happen, the exceptional case, that's why we have exceptions, and that's it. So, for example, a way to handle that is like, oh, if this is the node network, we know what to do. If it's I made a big mistake, I'll just report to the backend and I'll fix it later. And finally, there's something called deliberate violations. It's a big word. It's something, it doesn't happen that often, but it's really interesting. And one sort of example of that was the developers who used our callback API in a way we didn't expect. Sometimes developers do something that seems clearly wrong. For example, we used to have a class called fragment spy in our code. It was in the same package as fragments, and it was just trying to observe some values from it, to do a bunch of fixes and access to some APIs. This is clearly not an intended API, right? So when you find someone doing something really weird like that, usually you have to pay close attention, because what it means is that your API has limitations or your customers has needs that you didn't anticipate. So it's a great way to learn and improve your API. So this is kind of like what we talked about today. We want APIs that are easy to use, hard to misuse. Easy to use is intuitive, which means you have to have consistency. That's the easiest way to be intuitive. You have to guide people with doc and an API design. Example code should be exemplary. And then hard to misuse, we talked about preventing mistakes, correcting them, and violations. Thank you. So I think we have a little bit of time for questions. I also want to mention that Square has a booth with a photo booth that you can take pictures and then it prints them and it's cool and it's got like all this face, it puts some stuff on your face. It uses the Reader SDK also, but that's just kind of like to get you to try the thing. Square is hiring Android engineers. So if you're interested, you can talk to me, you can come to the booth. And if you have any questions, I think, so there are microphones there. There maybe is a volunteer, maybe not. But if you have a question, raise your hand and I'll repeat it for the recording. Yes? How do you abstract complexity in a way that you're no longer leaking complexity? So this is tricky. There's actually, someone said, it was pretty nice, it's like, Joel Polsky talked about that, how pretty much all abstractions are leaky. So the answer is you can't. The backside to that is that's why it's much nicer when you have access to sources, because even if you try to abstract, and I kind of didn't answer your question here, but when you abstract, if you can provide sources or provide a peek into what you're actually doing, then when things go wrong, people will have a much better time because they can understand what's going on and how things have been abstracted. That being said, finding that balance is really hard, and you will overshoot in one direction or another. It's easier to add more abstraction than to remove it. So I tend to try to go like, let's try to stick to like as little abstraction as possible. Like, in the domain side, we can have abstractions, but on the technical side, let's provide the primitives, the bricks, and let people build with it. And then we can also provide something on top, but we should still give access to the underlying stuff. So, I know it's kind of abstract talking about it like this, but you could say, well, I'm going to ship an activity, but you could also say, I'm going to ship a bunch of views. You could do both. You could say, I'm going to ship a bunch of views if you want to do it by yourself, but I'm going to have this activity for you. If you don't, you just want to get started quickly. And the activity that has the views is kind of a higher level abstraction where you don't have to deal with all that view stuff. The balance, the only way you can find your own balance is by dumping that onto someone's lap and say, go ahead and code and see how it works for them. It's easier to do on a quick start where they can just kind of go through. It's harder to find customers that have to go through a setup. But I don't think there's one answer. But it's the tendency that we all have is to over-abstract. So it's always sane to try to go into the other direction. Yes. Are there any steps we can take to proactively prevent any misuse of APIs? Well, I mean, yeah, so it's, first thing is finding them. So you have to do all that testing, all that feedback. And then it's all the things I talked about. So it's going to be, documentation is the last resort. But before that, it's about designing your APIs, having types. So basically, if you have methods that take object, you could pass whatever, and you're probably going to be wrong. If you have a stronger type, then it's harder to mess up. A typical one that you may know about is fluid APIs, and you might have seen that in some query languages where you can write things, and as you autocomplete, it changes the list of methods that are available so that you can only write them in the right order, which is really exciting and cool until someone copy-pastes a block of code somewhere else and removes a line because they try to tweak it, and then nothing compiles anymore. So this is an example of where a great idea like a fluid API can become really tricky to maintain when you're trying to change the code and everything stops compiling. Other than that, yeah, that's pretty much that. That's a great question. So how do you deal with upgrades, like major upgrades? Do you change the package or do you change the version name? I would say you should really try really hard to not make breaking changes, right? And have maybe deprecated stuff, keep it around for a while. I would definitely, before Square, I would maybe have done things differently, but having seen OKHTP do that, essentially if a large chunk of your API is changing, it is much better to change package because it also allows for gradual migration. You can have the two at the same time, which is a big advantage. But if that's not something you want, then probably same package is okay. But there's going to be a lot of communication that's going to have to happen to say, hey, this is a big change, this is everything you got to do, and people are not going to do it. So you really have to find migration path and maybe like libraries that help pipe one into the other and that kind of thing. Yeah. Yeah. How do you communicate those changes, those small changes like the login, logout? I mean, for us, that one was okay to do because we were still in alpha, so we just said, sorry, alpha, we broke you. But that being said, generally what I would do is I would probably add a new method, deprecate the old one, still keep it working, delegate, so you get a warning. Sometimes one thing that can help, if you want to be like more strict, you could say deprecated, and in the release, in a future release made after this date, this method is going to go away. So people know how long they can, they're going to have it around, and then they know that after some release, it's going to be gone. Yeah. With Kotlin, you could actually, it's interesting, you can start having more fun stuff. Like you could have extension functions that have the older method and keep it around available. And you could have an extension function, extended library that just provides bridges into the old APIs so that you can migrate progressively. I don't know if it's a great, I just had it on the spot. It may be a terrible idea. We'll see. We should probably wrap up, so have a great day. Thank you.